Yeah, g'day, and welcome back to this old lathe channel. Now, this lovely 125 CNC lathe from the Swiss company Schaublin was made with a CNC controller, which was state-of-the-art in the 1970s. Since I was not able to get this running, I decided to completely strip it down and modernize it. So I've had a couple of weeks off over Christmas, New Year's, and took the time to wire up and configure the whole thing. Let's take a look at it. Okay, so I thought I'd finished wiring all this up. My wife took one look at it and said,
"This looks like an art installation."
Last thing I did was to crimp all the Molex pins for that last connector. Once I was done, I still have one pin. So I counted and I've only got 9 wires for my 10-pin connector. Went back through and sure enough, this yellow wire here, I've connected that to switch pin 2. It should be on switch pin 1. I should have a grey wire in here somewhere. Guess I get to undo this loom again. Now I've got a couple of Molex connectors to do, and these little pins which go into them have these tabs which are a bit too long. Those are just the rear tabs which grip the wire. So I found by snipping those tabs down shorter, I get a much nicer result. To do the crimping, I've got these Japanese engineer brand Molex crimping pliers. They're really nice to use. It's the same brand as my solder pump. Good stuff. I'll leave a link below. Now that I've finished all this wiring, I'm gonna move out of my nice warm little office space here, take it all down to the basement and hook it up and test it. That means I can take a lot of this tooling away. By the way, do you guys watch Like Factory Made? He's converted a really nice Weiler E30 lathe to LinxuxCNC and shows some fantastic workmanship with it. So go and check out that channel. In good news, Santa got me another Mesa pendant interface card for Christmas. So now I've got one for the Schaublin's pendant. Speaking of Christmas, you know when I made Mrs. SMP this candle holder for Christmas, I also made her a little small binary version, but she was not into it at all. I didn't realize she'd hate it that much that she'd use it to try and burn the house down though. Now to connect my whole control panel, I'm using this Mesa 7i73 card. It's a pretty clever little card. It connects to the brain with just a single Cat5 cable. It includes decoding for encoders and also the matrix keyboard encoding. So it's quite a simple way to interface rather complex functions into the rest of LinxuxCNC. Now the other end of that cable is going to go to this card, the Mesa 7i85, and this card has got 2 functions. Along the bottom it's reading out 3 encoders for me, the 2 motor encoders plus the spindle encoder, and it's got 5 channels of RS422 serial connections. The first 2 are wired up to my main I/O card and my analog motion card, and then this one is going to be used to connect to the control head, all the switches, and one more will be used for my pendant when I make it. Now one thing I don't understand is why Mesa used these screw connections and have you terminate a Cat5 or Cat6 cable into a screw connection. I've already checked this cable, it's just the right length at what I need. Seems weird to strip down and terminate a bunch of wires. It would have been cheaper for them and easier for us if they'd just put RJ45 connectors directly onto the board. I did put a request through the LinxuxCNC forum to ask the designer of the Mesa boards why they went with a screw connection here instead of an RJ45 port. And Peter from Mesa responded on the same day. Basically, these devices are so flexible you can set up a bunch of different firmware to do all different things, and that's why he didn't want to lock it into the smart serial protocol with RJ45. Okay, with that all roughed up on the table, let's plug it all in. First I'll leave this disconnected and just restart the lathe to make sure nothing's changed on the lathe setup. Okay, that's good. LinxuxCNC still working as it did before. So now I'll exit from there, plug the new bits in. Okay, it's receiving power, light went on. So if we now open up this health show file, we should see pins for the 7i73. Alright. A couple of things should work straight away without any effort whatsoever. Haha. Let's look at code number 0's counts. So that's working. Alrighty. Looks like it's running backwards, so I might have to reverse the numbers on that. Now look at encoder number 2. Counts. Also working. Now look at encoder number 2. Also working straight off. Brilliant. Each of these encoders has also got a switch, a reset switch. Five, six, seven, and the knots, and the reversal, 5, 6, and 7. Fantastic. Right, with that working, I guess the next thing to do is connect those encoders. Now, I've got a very distributed HEL file.
Do you read me, Hal?
Affirmative, Dave. I read you.
Open the
Collets.
Hal.
I'm sorry.
Mark.
I'm afraid I can't do that.
Right, let's connect those 3 encoders. I'm going to be connecting into functions that are associated with the GUI, gmoccupy, and therefore they can only be loaded once the GUI has already loaded. So there's this custom post GUI HEL list. These are the items that get loaded after the GUI loads. In this case, source control panel.hel. So I'll save that. Now I'll make a new file. Control panel HEL file. This is the name of the pin, which has got that signal carrying the encoder count. So I'm creating a new signal called feed override, connecting it from there to gmoccupy feed override counts. So let's save that. I also need to do set parameter. Count enable, we'll set that to 1. Save that. Alright, now it's working. But in the opposite sense, but we knew that already. Guess we need I need to reverse. Need just to swap the polarity of the encoders to make them go in the right direction. Now the next thing we want is this button to reset the feed override to 100%. So now it's setting right. Next, I'll set the other 2 in the same way. Okay, the next thing I need to check is to see whether my LEDs are working correctly. So let's just go through and turn them all on. This one I might have put a wee bit too much resistance on. It does light up, but it's pretty dull. That goes off when that goes on. So I'm wondering whether the 7i73's got enough current to sync all of them at the same time. So basically, I have very little current available, where I thought each of the outputs could sync, so whatever an LED needs, it looks like you've only got 20 milliamps available for all. Okay, that's not good. In my last video, I talked about how to lay out a matrix keyboard, and I drew it like this, with this being like output 0. And then I talked about connecting the switches through rows out to the side like this. Yeah, a lot of people pointed out straight away that that was nonsense. This switch would have to be closed for any signal to ever get to switch number 2 or switch number 3. The way it needs to be is actually this. And the switches have to bridge between a row and a column, like this, I guess. So sorry about the confusion, but if you're going to do a matrix keyboard, probably find a better reference than me to how to do it. Now the next thing I've done, I edited this control panel HEL file to add all of the matrix key assignments. So how do we do that? First up, in the main HAL, we load a real-time component called matrix keyboard and tell it it's a 8x8. Although I'm not using the full 8x8, it has to be defined like that because that's what the Mesa card needs. We add that function to run with the servo thread, and the servo thread runs every millisecond. One of the cool things about the Mesa 7 i73 card is it's got the pin assignment in its firmware, so I don't need to go through and tell the system which Mesa pins are the 8 outputs for the matrix keyboard and which are the 8 inputs. It does that automatically and generates just a single key code. And that key code I then connect into the matrix keyboard's key code, and that generates my 64 pins. So each of those matrix intersection points are now a pin available to be assigned. And I have a look at pins. You'll see there's now a matrix keyboard, and those 64 keys have been defined. And so you can see it's coming from the matrix keyboard and going out to the Gmocker Pi button 0 at the top there. Now if we watch that, doesn't seem to do anything. Now before I do my first troubleshooting step, I'm just going to speculate here. I got 7 output pins and 6 input pins. Because I added diodes to every switch, I added polarity to the system. So I'm going to speculate that I wired the outputs to the inputs and vice versa. To try and understand this, I've put lab power supply on 3.3 volts. Got a blue LED here. So this is my plus line, which is simulating my output pin from the Mesa card. That's connected to pin number 3. So an output pin number 3 is key 0 output. So that should be right. When I click on it, sure enough, it lights up fine. Let's move that over to the next pin, which will be pin number 4. I did the troubleshoot and it's not as bad as I feared. It seems to be all correct with the exception of this one purple wire here is connected to the wrong location down on this board, so I still need to repair that. But by disconnecting the wiring from the upper panel, I now do have the first inklings of some functionality. So if we look here at the coolant buttons, turn them on, off, both flood and mist cooling. So that means the matrix keyboard is now communicating. Joystick jogging's not working, so I need to look into that. While I was in there measuring the wiring, I also switched around the phase A and phase B on each of these 3 encoders, so they're also now working in the correct sense. And after a bit of mucking around, I also got the spindle pins connected. Start counterclockwise or clockwise. Now when I turn on the spindle, so that speed override bias is working in the forward direction, but in the backwards, it doesn't. Okay, after checking my wiring diagram, here's this error here. This purple wire connects to pin 1 on this button. The purple row is the second row, not the first row. Move that down to, oh, there's a 1 there I can use. Now, of course, the next issue is that this wire is too short to reach over to here. If I had another pin for this connector, I'd simply crimp on a new pin and run a new wire. But I don't. So what I'll do is just extend the existing wire with a solder sleeve. I do have some more purple wire there. That's about as much as I got done before we headed to Corinthia to celebrate the New Year's Eve with our friends. And since New Year's Day was such a nice day, I decided to go skiing. Not sure what happened to the audio there. Now you're probably wondering, what's skiing got to do with a CNC retrofit YouTube channel? Well, I'm glad you should ask. My best mate in high school, Andrew, his family skied, and Andrew was allowed to take a friend with him, and that was very generous that he took me. So that's how I learned to ski. But also, Andrew's family had a CNC production engineering company called TPE, and Andrew used to work there some evenings as a cleaner, and sometimes I'd go along with him, just hang out. So it was through that friendship with Andrew and with his parents that I kind of got an affinity for CNC machines, which has grown ever since. So Andrew, Arthur and Kerry, thanks a lot. And I love doing a last run of the day. So lifts close at 4 o'clock. Yeah, 3 minutes early. Not bad. Right now I just got to get back to my car in one piece. It will have been a fabulous day. Looking at my ski line, I did 68 kilometers that day. This Gmocker Pi interface has got a manual jogging in selector here, where you can have fast jogging with the rabbit, or you can click to have slow jogging with the tortoise. And if I'm in tortoise, one click gets me into the rabbit, but if I'm in the rabbit, it stays there. Touching on the touch screen, it's just a momentary selector. With this external button, I've got different behavior depending on the mode. So I'm suspecting that Norbert, the creator of Gmocker Pi, has, as a safety feature, made it so that the tortoise, the safe mode, is sticky, and you have to hold the override to get the high speed, in which case I need to invert my signal here because I've got exactly the opposite, where it's defaulting to the unsafe high-speed jogging. I'm trying to troubleshoot why some of my switches are working in the matrix and some of them are not. And what I've come up with seems a bit screwy to me. Let's just look at this switch here first. We're looking at vertical button 0. It's connected between pin 3 of the Mesa card and pin 11. Pin 3 should be an output, so I want my power to come in through pin 3, and pin 11 is the input, so that should be closing my circuit. What I've got set up here, I've got a lab power supply over here set for 3.3 volts. I've got the negative terminal with a blue LED attached to it, which will hopefully be visible, and that's connected to my pin 11 here. On the other side, I've got my 3.3 volts positive coming down and connecting to pin 3. So now when I push the button, the LED lights up. So you would think that that should all work. However, if you look at my power meter and the current flow on my lab power supply, there's not enough current flowing through this LED to trigger it. Let me just bridge that diode with a conductor. So when I bridge it, my blue light's brighter, and you can see on my lab power supply I've got about 400 milliamps and about 0.15 of a watt of current flow. Take my bridge away and it drops back. I've got my multimeter set up for diode test mode, and if we test the forward bias, okay, a bit over a 0.6 of a volt, and open circuit in the other direction. Just to compare that with my unused new diode, .6, and if we run along and look at all of them, that value does seem typical. Now, as I do have a few switches which are working, I had a look at what's different about these switches than the ones that aren't. And what I found was the switches that are working, I've got a closed circuit bypassing the diodes. If you look at these little breakout boards I'm using, you can see they've got these little diode jumpers. I had a look at them and some of them were already open from production, and I've got the feeling that all were open, so I stopped trying to cut that trace. Along those three, those diode jumpers are still working, taking my diode out of the circuit. I know I can get the whole thing working if I just remove all of the diodes and just jumper them all. What I don't understand is why my diodes, which appear to have the correct polarity, are resisting current enough to only flow such a slight current that it doesn't even show up on my lab power supply, but is enough to light up a blue LED, so to medium strength. Don't get that at all. I put in a query through to Peter, who designed the Mesa boards, at 2:41, just describing what I got, and man, how's this for service? 12 minutes later I got a response from him. He suspects I probably screwed up my diode polarity, which, given the way I work, is definitely a fair judgment. And since there's no real need for diodes in its keyboard matrix, I think I'm just going to rip them all out. I provided Pete with a better description of how I wired this, and he's reported back that the output pins from the 7i73 are actually sinking current. I had assumed that an output pin would be the positive terminal putting out the 3.3 volts, and that the input pins would be negative and would be reading the state. Because of that, it means all of my diodes are reversed. Because I set this up with two different pin heads, this one being what I thought were the outputs and this being the inputs, maybe there's enough slack in my wire if I cut the lacing to be able to switch those two around, in which case the whole thing should then work. That of course means, because I'm transposing my rows and columns, I'm also going to have to transpose all of the buttons in the matrix, so I just had to go through and redo the button assignments in my HAL file. Cool. So that means both of those are now working. Woohoo! I've just gone through and tested it all, and now all of the hardware connections are in there and working, the whole matrix. That means I can now install everything into the control module, put it on the lathe, because the rest of it is just some of the functions still need to be configured in firmware. But yeah, let's get it all installed. So first I need to mount the control unit's pivot arm, and it's got this little slot to restrict its range of movement, and this nut goes inside. So I figured, well, if I superglue the nut, then I'll be able to just put the bolt in. Yeah, nah. Right, well, after trying and failing with super glue, I think I got a new plan. So I've put a wedge on a cord, and that's going to come up through the tube from below, pack out the tube with a bit of wood, and the wedge can hold the nut in place. Put the arm on top, put the bolt in, and once it's done I can pull the wedge out from below, and it all's going to work perfectly first time. I'll just use a screwdriver to drag the wedge up a little. Okay, that doesn't work. Okay, that's going to work perfectly. Oh wow, cool. Really did work first time. Now the beauty of using that little Mesa interface card, I only need one power cable for the PC, one Cat5 cable from the PC down to the brain Mesa, another Cat5 from the brain back up to the interface card, and one extra cable for the e-stop discrete wiring. Right, next up, let's mount that monitor. I got some of this electronic repair tape to seal the monitor against its frame. It's only quite narrow. I printed out some symbols to go under the keycap covers. Okay, let's start from the top. The keys I'm using for this project are the MX keys blue, which I think are the clickiest of all the keys that they make. It's pretty hard to resist clicking them all the time. I probably didn't give quite enough clearance in my cutouts, so I've got a few little sticky keys that I'm going to have to address. This one, maybe that one, and this one. Right, let's make sure I've got my e-stop set properly. So start a spindle, shut it off with a foot switch, shuts down, e-stops, can reset it off the touchscreen. Start that spindle again. So in this build, I'm doing a hardware e-stop with a safety relay. This unit's got a set of contacts which get dropped immediately. It's got some that get dropped with a 1 second delay. I've set a second here. So that's going to be the axis drives and the spindle motor stay powered for 1 second. That gives it a chance to power them to a halt. So the foot switch is on channel 1. The panel e-stop is on channel 2, I think. Yeah, channel 2. The condition of the e-stop gets fed back to LinxuxCNC through these first contacts. And if LinxuxCNC triggers an e-stop, it comes in below there. Next, I need to configure a few things which require more complex logic. For this, I'll use LinxuxCNC's Classic ladder. I've now modified my ladder logic for the back gear. So at the moment I'm in high gear, 1 press. Now I'm in low gear. I'm in low gear, hit the back gear button, nothing happens because I've got an inhibit in there. Oh, I need an inhibit not on spindle on, but I need an inhibit on spindle stopped. I have to go looking for that. Okay, I've now added a comparator into that back gear logic, so it can only change gear when the speed drops to 0. I've got no more air in there now, but it now swaps between them. Awesome. Right, since I also want the same sort of inhibit on the collet opening and closing, and also on the tailstock, I don't want that to release while the cart's spinning, I'll quickly go and add those. Let's try out our variator system. So if I start the spindle, so variator down, variator up, I'm using offside inhibits. If it's speeding up, in the second that it's moving, if I push the down button, it should not do anything. Let's try that. I've added a timer here into the circuit on each line, so every time I push a button, either up or speed change down, it does 1 second of power to the variator adjustment motor. Change to back gear. So I've just moved those inhibits up to the input to the latch. So now, anytime the spindle's moving, it will ignore a gear change request. Let's try that. Pushing the gear change. Shut down. When it gets to 0, once it's stopped, no gear change. Gear change works when stopped. My variator's now working. I can push the button. It will do nothing while I'm stopped. But if I start the spindle, okay. My tailstock fitting's got a bit of a leak. So if I go tailstock retract, it's not a tailstock extend, those are working nicely. Now let's see if it's inhibited when I start the spindle. Yep. So it has to be completely stopped to command the tailstock. All right. Right, well, other than a couple of rather minor software niggles, which I'm going to have to ask about on the LinxuxCNC forum, I've now got all of the functionality I had working before, working through this control panel with a much better interface already. Still got a bit more to do. I need to put some markings on the 3 encoders before I can put the knobs on them. I'm going to have to get into this tool holder and get it working and get it tied in with its buttons. I don't have any coolants set up, but electrically all this is working. Real milestone. I'm super happy with how this is coming out. I'd say that my design goals for that control panel are being met. I'm pretty darn happy with it. Well, thanks a lot for watching. I'll see you next time.